Okay, today we're going to talk about inequalities for one triangle. Okay, so if I have one triangle, let me show you one triangle here. Jason, what can you tell me about this triangle? Triangle ABC. It's an isosceles triangle, right? So class, what can you tell me about the two base angles, C and B? Tony? They're congruent. That's easy, right? Because of the isosceles triangle theorem. Now, but that's not what we're talking about. Today we're talking about inequalities. So, of triangle. So if I have this, take a look at this triangle, RTS. One side is 13, the other is 12. What can you tell me about this triangle, Josh? Angle T is greater than angle S. Really? You think T will be greater than S? You think it's S? Okay. How many people think? All right. Go ahead. Everybody discuss this. Think. I'll wait. What do you guys think? Oh, wait. All right. How many people think S is greater than T? Raise your hand. How many people think T is greater than S? Okay. How many people have any question? Yeah. How many people think S is greater than T? Okay. You guys are correct. It turns out S is greater than T in this case. And then we're going to show you why in a minute. Is that okay? Anybody guess why S is greater than T? Yes.
13.
Right. So this side is 13. The side opposite of S is 13. Side opposite of T is 12. That's precisely the reason why angle S is greater than angle T. Does that make sense? And we're going to actually prove, yeah. It's not because of its... Yeah, because... Let me show you. So who wants to read this part? Using the information above. Go ahead, Brianna.
Does not equal measurement angle T. The following theorem enables you to reach an even stronger conclusion. The conclusion that measurement angle S is greater than measurement angle T.
Yeah, and we're going to show you why this happens. Okay. So, like I said, it's not because it's 13, it's because this is 13 and the other is 12. In other words, the side opposite of this angle S is greater than the side opposite of the other angle. That's the reason. Does that make sense? So, here's the theorem. The way they describe that picture above is this. If one side of a triangle is longer than a second side, isn't that what we had before? Then what can we conclude about the angles opposite of those sides? The angle opposite of the first side is what? Larger or smaller? Larger than the angle opposite of the second side, because the first side was longer than the second side, wasn't it? And here's a picture. If you have a triangle RST and RT is longer than RS, right? That means measurable angle RST is going to be greater than measurable angle T. Okay.
Do you draw it?
You don't have to. It's up to you. But I do want you to write down the theorem at least once. And if you don't really understand what this theorem is saying, maybe drawing it will be very helpful, right? So, do you understand what this theorem is saying?
Yeah.
Okay, let's go about proving this. Anybody know how? Okay, of course, this dotted red line, guess what? That's going to help us to, prove this, right? This auxiliary line. Now, how are we going to draw this one? Anybody want to guess? Actually, you know what? Let me give you a hint. We're going to draw this so that angle 2 and 3 are congruent. That's the key. So how would you draw this one? If I want to make sure that angle 2 and 3 are congruent. How would you draw this auxiliary line? I want to make angle 2 and 3 congruent. 1, 2, 3, 4. Samantha, how would you draw it?
So that Z is the midpoint of the hypotenuse? Oh no, so that RZ is congruent to RS.
Exactly. If I want to make sure that angle 2 and 3 are congruent, right? Isn't there a point on RT such that the distance from RS is congruent to RZ? Yeah. Right?
Midpoint.
Is it a midpoint?
Oh, a right triangle.
Is it a right triangle?
No, it's not right.
No. We just have to make sure that RS is equidistant from, RS is same length as RZ, right? Isn't there a point on RT such that the distance, right, RZ will be same as RS? Yeah. So by Rudolph postulate, that's what we have. As soon as you have that, guess what? Because of the isosceles triangle theorem, what can you tell me about angle 2 and 3? Congruent. Right?
Yes.
Austin, won't you read this for us?
By the ruler postulate, there is a point C on RT such that RT equals RS, ST, and isosceles triangle RZS. Measurement
Right? Isn't that what we have? Are we good? Yes. Okay. So if that's true, let me ask you something. What can you tell me about angle RST versus angle 2? First of all, RST is made up of angle 1 and angle 2. Would you not agree? Okay, so if that's true, I mean, because that's the whole angle, right? If that's true, what can you tell me about angle RST versus angle 2? Brandon?
Angle 2 is less than angle RST.
Exactly, angle 2 is got to be less than angle RST. Would you not agree, guys? Because RST is made up of angle 1 and 2 together, right? What property am I using there? Well, angulation postulate says yes, RST is equal to measure of angle 2 plus measure of angle 1. But if I say RST is...
Or definition of inequality.
There you go. The reason why angle RST is greater than measure of angle 2 is because of the property of inequality, right?
Oh yeah.
You guys remember that?
Yes. What? Wait, this is not a inject proof.
No.
We're done?
No. Are we done? Is that what we wanted to prove?
No.
We didn't want. We wanted
We're
to.
done with inject proofs. Yes.
Oh, are you done with? Yeah, but
Just to use it.
yeah, so you could still use it. But this time I'm just doing it directly. There'll be times where we use indirect proof. All right. So are we okay with this so far? All right. So as you can see, then it's sort of obvious, right? By property of inequality, right? Angle RST is greater than measure angle 2. That's obvious. Is that right? Okay. What can you tell me about then RST versus angle 3? Jason. It's bigger. Who can tell me why? Yeah, Jechan? Substitution, because we were talking about measurement. Right? Because what do you know about angle 2 and angle 3? They are congruent. So could we say this also? By substitution? Are you all following me so far? Okay, so that's great, but is this what we wanted to prove?
No.
No, we want to show that RST is greater than angle T. So how are we going to do this from here? Let me give you a hint. I would like you to take a look at this triangle TZS. Okay? What kind of angle is angle 3 in terms of this triangle? It's an exterior angle, right? Do you know something about an exterior angle?
Yes.
I want you to, okay, so I want you to tell me who knows something about the exterior angle. How about Tony?
Exterior angle equals the sum of measure of 2
Yes. So angle 3 is equal to Jonathan what? Sum of angle?
Angle T and
Angle T and angle 1 is exactly right. Would you not agree?
Yes.
Okay. But is there some other theorem that tells us something about the exterior angle in terms of inequality? I want you to discuss with your group. Go ahead. Discuss with your group. Alright. Raise your hand if you know the theorem that I'm talking about here. Who have not called? I haven't called. Nicole. Do you guys remember the exterior angle inequality theorem?
Yes.
We know that angle 3 is sum of angle T and angle 1. But what does the exterior angle inequality theorem tell us? How about Kristen? Either. It's going to be greater than either one of those remote interiors. So it's got to be angle 3 is greater than angle T. Can I say this right now, right here? Yes, I can. Because angle T is going to be less than angle 3. In other words, angle 3 is greater than angle T. Can we not say that? Because of what? Exterior angle theorem. Exterior angle inequality theorem, right? So, if that's true, we're almost done. Anybody see what we could do afterwards here? If this is true, what can we say? If, let me give you a hint. Okay, it says RST is greater than measure of angle 3, and measure of angle 3 is greater than angle T. What can you say? ST. A lot of you? Okay, not too many though. Go ahead, discuss with your group. So what? What are we gonna say next? So, let me again show you. We got angle, measure of RST is greater than measure of angle 3. Measure of angle 3 greater than measure of angle T. Who can tell me what to write next? Samantha? By the property of inequality. Is this because of transitive?
No.
Is it because of substitution? I heard a lot of people saying that. It's because of the property of inequality. If A is greater than B and B is greater than C, what can you tell me? A is greater than C. You guys remember that one? So do you see why RST is going to be greater than angle T, because you got RT greater than RS? You see how that works? Any question on that theorem? Yes?
We have to do it like that.
I'm sure there are other ways of proving, but
I mean, can we do two column proof?
yeah. But this is sort of a summary of that two-column proof, isn't it? Yes, Kevin?
So you can't use substitution when there's inequalities?
Yeah, this one. Yeah, substitution only works with when equality, equal sign, right? So please be careful. Don't say substitution at the end. Then it would not be correct. All right, may I move on to the next theorem? Yes. All right, here we go. Okay, who would like to read this for us? Okay, go ahead, Jonathan.
One angle of a triangle is larger than a second angle, and the side opposite the first angle is longer, and the side opposite the second.
Okay, if one angle of a triangle is larger than the second triangle, then the side opposite of the first angle is of course longer than the side opposite of the second angle. What does this sound like? Sounds like what, Young? Converse of the previous theorem. Would you not agree? Yes. Okay, so turns out the converse of the previous theorem still works, and that's what we're trying to say. If you have a triangle and you notice that angle S is greater than angle T, guess what? RT's got to be greater than RS. Okay, so write this down. I'll give you time. All right, so it turns out to prove this theorem, we can use, Austin, guess which theorem, which method we're going to use to prove this? No, we're going to use the one that you asked. We're going to prove this theorem by indirect proof, or call, another way to call that is call proof by contradiction. Okay, so we're not done with it. We could actually use these. Okay, so this one we're going to use that. Okay, so everyone should be able to tell me the first step. Okay, Kevin, what should be the first step if I wanted to prove this using proof by contradiction?
Assume temporarily that RT is less than R, or less than or equal to.
Good. It's not just less than, is it? Is opposite of greater than same as less than? No. It's less than or equal to, right? Question?
We did not greater than.
Okay, so actually, if you say that, then that's what they did, okay? But if you do this, what does this mean? You have to know that this really means?
Less than or equal.
Yeah, so then you have two cases. Either RT is equal to RS or RT is less than RS. Does that make sense? So it turns out you can't really do this with less than or equal to as one step. So you gotta have sort of separate this into two cases. But it turns out the first case where RT is equal to RS is sort of easy because you could see the contradiction right away. What happens if RT is equal to RS? You see this RT? If this RT is equal to RS, what is your contradiction to given information here? 1, 2, that's it? 4. Iveta? Why? Because if RT is equal to RS, what happens? Exactly. If RT is equal to RS, what kind of triangles do you get? Isosceles. So guess what? Angle T is congruent to angle S. Well, that's a contradiction to the given fact that measure of angle S is greater than measure of angle T. Is that okay? So that's easy. All right. So case 1, there's your contradiction. All right. What about case 2? What happens when RT, this one, is then shorter than RS? In other words, if RT is less than RS, 1, 2, 3 people see it. That's it. How can you draw your contradiction from here? 4 people. Go ahead, discuss with your group. See, and now I'll about Nicholas. Can you tell us what happens with case 2?
You could say that the measure of angle T is greater than the measure of angle S.
Right. As soon as RT is smaller than RS, measurement angle T got to be what? Greater than measurement angle S, which is a, well, yeah, it tells why. The reason is because of the previous theorem that we just talked about. And isn't that a contradiction to the given fact?
Yes.
Yeah. Does that make sense? As soon as you make RT less than RS, because of the previous theorem, right? Because RT is less than RS, angle S is smaller than angle T, which is direct contradiction to the given fact, right? We said that angle S must be greater than measurement angle T, right? So therefore, what have we done here? Kevin?
It contradicts the given.
So how are we going to say this? After this, we're going to say, therefore,
the temporary
assumption.
is false.
Mm-hmm.
And it follows that RT is greater than R.
There you go. Does that make sense? In either case, the contradiction, right, is contradiction to measure S greater than measurement T. The assumption must be false. Therefore, RT is greater than RS. Yes?
How do we know when to?
Good question. How do we know when to use these? You don't. I mean, so you first basically try the two-column proofs, right? Because that's what we're used to. And then if that doesn't work and you have no choice, you would use this. But on the test or stuff like that, they're going to actually give you some hints. They're going to say, try to use these. Okay, so does that make sense? They're going to actually tell you what you want to use. Yeah?
So in our homework,
Mm-hmm.
if we're doing two columns and it doesn't work, then we have to do then like erase that.
Yeah, but 90% of the time, two columns will work, okay? Unless it's, yeah, two columns. Unless it says to use the other one. So we'll give you some hints on this. Okay. All right, but I see what you mean. Here we go. From that theorem, we get two corollaries. The first one, somebody read this for us. Jason?
A perpendicular segment from a point to a line is the shortest segment from the point to the line.
Okay, what does this mean? Write this down. As you write this, think about what we're trying to say. The perpendicular segment from a point to a line is the shortest segment from the point to the line. Explain to us what this corollary is saying. What do you guys think it means? One person knows? Two? Tony, what do you think?
Well, it means that from a line to a point, the shortest distance from the point to a line is like a line, a segment perpendicular to the line.
Yeah, guys, do you guys remember this from the other time, Kevin? What does this remind you of?
The
Definition of?
line, the distance from a line to a line.
The definition of the distance from a point to a line, right?
Yeah.
And that definition didn't tell us anything about that's the shortest distance, but now we know. I mean, we kind of knew that already, right? So take a look at this picture. Here, I got a point outside the line. Oops. Here, there's a point outside the line, right? You see the segment AB? That's the perpendicular segment. How many segments can I draw from that point A to the line L? Infinitely many, right? I could draw a whole bunch. Let me draw this one right here. Is that okay?
Yeah.
And I could draw this one, right? I could draw this one, but let's just take a look at that one. What can you tell me about the distance from AB versus distance of AC? I mean, the length of the segment AB versus length of segment AC. Jonathan?
AC is greater.
AC is greater than AB. Would you not agree? And that's what this corollary is saying, right? Right? It's sort of obvious if you look at this picture, right? Now, how would you go about proving this, though? And why is this related to? Because you know these corollaries come from these theorem, and these corollaries could be proven easily using the theorem above, right? So how are they related? Two people see it? How are you going to prove this corollary using that theorem above? Go ahead, everybody discuss with your group. I'll wait. Think about it. How would you do this? All right. So anybody see how they're related here? How about Amy?
Okay, so if the bigger angle is bigger, then the opposite side of the angle is bigger.
Okay, I get what you're saying. So Amy, what can you tell me about the side AC versus side AB?
It's bigger.
It's bigger.
Which one?
AC.
AC is always going to be longer than AB, and the reason why you're saying is Amy because this angle ABC is always going to be bigger than this AC. Let me call it angle 1, angle 2. Right? Do you see how angle 1 is always going to be greater than angle 2? Would you not agree? Because in a triangle, how many right angles can you have? One. And this angle is going to be right? Because it's perpendicular. Therefore, angle 2 has to be less than 90, right? Therefore, AB is going to be always shorter than AC, right? No matter what kind of, right? However you draw the AC, right? It doesn't matter. This angle is going to remain 90 degrees, right? And so, of course, this angle is always going to be less than that. Do you see how it's related to the previous theorem up there? Okay? Does this make sense? Yes, Kevin?
So,
Go back to the picture.
just use the definition of the hypotenuse.
Definition of the hypotenuse.
Is that the longest?
Ah, okay. Is that what the definition of the hypotenuse say about right triangle? In our head, we know it's longest, but it doesn't say it's longest, does it? It just describes what it is. It just says it's the side that's opposite of the 90 degrees. So you can't really use the definition of the hypotenuse. Even though, yeah, you're right. In a right triangle, the hypotenuse is the longest side. The definition doesn't say that. Yes, sir. Question.
You know how CB,
Yes.
can't you make it shorter than AB?
Yes. So, but does that matter? Are we talking about CB at all?
No.
Are we comparing the distance from CB to AB, or are we comparing the distance of AC to AB? Right, Jason? Look at what we said here. The perpendicular segment from a point to a line, right, is the shortest segment from the point to this line, right? Is CB, right,
Yeah.
a segment from this point A to the line L? No. Does that make sense? So I know what you're saying. Yes, you could make CB shorter if I put C right here, right? But that's not what we're discussing. We're discussing this AC versus AB only, right? CB has nothing to do with this point A, does it? Does that make sense? Okay. So that's a good question, but we don't care about that size CB there. Okay, any other question? Okay, so we could actually sort of expand this a little long more by saying, not just for a line, guess what? For a plane, who would like to read this for us? Corollary 2? Go ahead, Austin.
The perpendicular segment from a point to a plane is the shortest segment from the point of the plane.
Yeah, so instead of point to a line, guess what we're talking about now? Point to a plane. And guess what the shortest distance from a point to a plane is? It's the perpendicular segment. From, right? Point to a plane. And do you see why? Do you see how it's very similar to this here? Same idea. Okay, so go ahead and write it down. Oops. Show it to you here. Move it up a little bit. Here we go. Go ahead. Write this down. And do you see how it's very similar to the previous one? I guess I'll show you both together. Okay, instead of point to a line, it's just point to a plane, okay? So, the last theorem of the day is called the Triangle Inequality Theorem. It's got a name, sort of nice. It says, the sum of the length of any two sides of a triangle is greater than the length of the third side. Okay, and here's a picture for it. What is it saying? It's saying something sort of simple that you should already know. As you write this down, think about what it's saying. Okay, go ahead. Go ahead and write it down. So Dylan, what do you think this is saying here? Yeah, when you add the two sides, right, it's got to be what? Longer than the third side. So let me ask you this question. If I have three segments like this, 2, 5, and 1, is it possible to form a triangle with
No.
length like 2, 5, and 1?
No.
Why not?
Because
Yachan?
if you add 2 and 1,
Yeah.
it's not greater than 5.
And so, basically, why not? So what? So what? Why can't we form a triangle? Jason?
Because they won't connect.
Yeah, they won't meet, right? It's too short, right? Even if I make this 2 and 3, would it work?
No.
No, it's too short, right? Even it'll be just exactly 5. That's why they're saying this right here, right? It's sort of obvious. They're saying the sum of the length of any two sides of a triangle is greater than the length of the third side. And they tell you, look, AB, where's AB? AB plus BC, when you add those together, right? It better be greater than what? AC. AB plus AC has to be greater than BC, right? And where AC plus BC, no, AC plus BC has to be what? Greater than AB, right? This has to be true. So we have to now prove why this is true. So let's take a look at how we go about proving this. Take a look at, let's just assume that AB is the longer side of a triangle. Now, is this always true? That there's always one side that is the longest in a triangle? No. There's one case where it's not. Equilateral. Then, guess what? AB has to be the same length as the other two. So that's what they're saying. They actually don't forget that. So, or AB is the at least what? As long as each of the other side. Which means what? It's a equilateral triangle. Does that make sense? But if it's not an equilateral triangle, wouldn't there be a side that's going to be the longest? Right? By the way, when you're actually doing this, would you try all three cases, or would you compare the longest side versus the other two sides? Yeah. Wouldn't you do that? Wouldn't you compare the longest side versus some of the other two sides? Right? You don't try all three, right? You just try the worst case, correct? So you make sure that the longest side, right, compared to the two other sides, right? Does that make sense? Anyway, so if we assume that AB is the longest side, or AB is, of course, at least as long as the other two sides, it says the 1 and 2 are true, sort of obvious. Why? Why is 1 and 2 sort of obviously true? Tony?
Because AB itself is longer than AC and BC.
Yeah, AB is already, starting with, AB is already longer than AC and BC because we said it's the longest side. Well, what if AB is same length as AC?
Well, then BC and AC...
Yeah, you're adding BC and AC to AB. Therefore, 1 and 2 are obviously true. Is that okay? Right? Does that make sense? Now, the interesting case is the third case, right? If AB is the longest side, then is this going to be true? AC plus BC, right?
Yes.
How would you go about proving this, right? That's the interesting part. Isn't that right? Part 1 and 2 is sort of obvious, right? By the property of inequality, right? That's sort of obvious. Is that okay? So how would you go about proving 3? Yeah, Jason?
Angle ACC is the greatest angle, right? In that triangle.
Okay. So this angle, whoops. Yeah, you could go that right, but let me show you, before you do that, let me show you something, Jason. Let me ask you this. What can you tell me about, Jason, the length of AZ versus length of AC? Since AZ is a line, and A is the outside of this line, what can you tell me about the length of AZ versus AC? AC is longer. AZ is shorter. Because of what?
0.62.
Kind of. It's because of the corollary, right?
This segment.
Yeah, the segment outside the point, or the perpendicular segment, right? So the line is the shortest distance, right?
The shortest segment.
What about BZ versus BC? Which one is shorter? Since CZ is perpendicular to AZ,
BZ.
BZ is shorter than AC. Would you not agree? Because of the corollary, right? Right before this, right? Okay, so keep that in mind. If that's true, oops, let me try to hide the answer. Okay, so you know that AC is greater than AZ, right? We also know that BC is greater than ZB, right? Would you not agree? Because of the corollary. Now, if that's true, could I use, is it okay for me to say this?
Yeah.
AC plus BC is greater than AZ plus AB? I mean, AZ plus ZB?
Yes.
Where do I get this from? What's the reason? Property of inequality. Look, isn't this a property of inequality? Okay, so A greater than B and what? C greater than D. What can you tell me about A plus C versus B plus D?
A plus C.
A plus C is greater, right? Isn't that the property of inequality? One of those 5, right? Now, if that's true, what is AZ plus ZB, guys? By segmentation postulate, what is that? BA, right? So, isn't that same as AB? They said by substitution, right? And if that's true, what have we proved? The theorem, right? That what? AC plus BC has to be greater than AB, and there we proved it. Does that make sense? Yeah. Do you understand how that works? Okay. Any question? Do you see how the first 2 cases are sort of trivial by a property of inequality? And then the third case you could use to prove that third case by using the corollary. Okay. Any question? Do you understand? Yes?
Yes.
Okay, good.